In 1826, two men of science set out to measure the weight of the Earth, and their chosen location was Cornwall.
We're here at Rosevale Mine, just outside Zena, and the original experiment happened at Dulcove in Poole.
During the 1820s, Cambridge was home to a network of incredibly brilliant mathematicians, two of the most successful of which, George Beadle Airy and William Whewell, came down here in 1826 to perform a series of experiments using a regulating clock and pendulums to measure the density of the Earth and its influence on how a pendulum beats, the speed at which it oscillates, because this is very important to chronometer design. You need to know how much impact the Earth's gravitational force is having on a pendulum to be able to build incredibly accurate clocks, which you need for effective navigation. William Whewell was the son of a carpenter from Lancashire. He would go on to become one of the most influential men of science of the 19th century, becoming Master of Trinity College in Cambridge in 1841, which of course was the most powerful of the Cambridge colleges. He was generally regarded as a polymath. He was a specialist in the science of tides, in fact pretty much invented that scientific subject. But he was also a brilliant mathematician. He'd been on the Cambridge undergraduate mathematics tripos and performed exceptionally well. Cambridge was actually home to a mathematical renaissance during the 1810s, and Whewell had been very much part of this. His partner, George Beadle Airy, would become equally eminent, becoming Astronomer Royal, responsible for Greenwich Observatory in 1835. But in 1826, he, like Whewell, is interested in this question of the Earth's gravitational force, because that's a fundamental mathematical problem. And they were looking for a mine that was deep enough to perform these pendulum experiments, and eventually they determined on Dulcove, down here in Cornwall.
We're here at Rosevale Mine, just outside Zena. We're doing this as part of the Maze Creative project called Above and Below, and we have been funded by Heritage Lottery Fund, Scientific Instrument Society and the Royal Astronomical Society.
We needed two pendulums. One was compared to the other in the experiment, and I sourced a pendulum from one of my clocks by a James Cumming of Falmouth, which is from about 1760, and also one from William West, who was Richard Trevithick's brother-in-law actually, and that came from his clock. So those were adapted to work with a different regulator clock, and had to make new mountings, and we set this up in the mine to see how well it would work. We haven't done this before, so that was an experiment in itself. I'm pleasantly surprised that I didn't have any expectations really. I didn't know if it would work or not, but it is interesting seeing the science coming out of it.
So these experiments are important to understand the gravity and how gravity works, but also how magnetism works around the world. And this becomes very important when it comes to navigation, because one of the key equipments for navigation were compasses. And compasses work based on magnetism and magnetic forces. So by understanding how the different magnetic forces work at different locations on Earth, you are able to improve navigation itself. Then you are able to get items, ship items from one place to another at a much quicker rate. Your journeys on sea or even on land become much quicker. So it is absolutely essential to understand what are the effects of nature on these scientific instruments that guide us on a daily basis.
We're in the middle of the mine, we're measuring the influence that all of this mass, all of this rock around us is having on the pendulum. And we're recording how many times the pendulums correspond, how many times they beat in time. That's called a coincidence. You count the coincidences. In the 1820s, they did this for hundreds of hours. This went on for days, for weeks. We'll be counting a few every hour, hopefully, over the next few hours.
So we feel like dressing up as part of it is also attempts to experience the heat or even the cold of the mine itself, and how is that actually affecting how we are using the instruments. It gives you a really good idea of how much work and how much planning, and also just how radical this experiment looks, because you are literally bringing precision instruments down into conditions that are wet, dirty, absolutely terrifying, and there is complete darkness sometimes, and it's following those footsteps. It's been a fantastic experience and very, very fruitful.
Basically, you put these two pendulums in action, in motion, and from a distance you set up a viewing platform with a small telescope. We used a 19th century telescope, and you look through the telescope and you pick out the white dot on the pendulum inside the regulating clock. Free pendulum outside of the clock beats in sync, and when they're beating at exactly the same rate, when the outside pendulum is exactly in coincidence with the inside pendulum, the white dot disappears. And today we've been in here for 3 hours, and we have recorded the dot disappear about once every 44 to 45 minutes. Which, given that we've never done this before, we've never done these experiments, we're all really unfamiliar with it. That's an incredible result. I mean, it actually does work. It's just we're not quite perfect. And I'm going to steal thunder and say this on behalf of Caroline Kennett, who was the observer of the first coincidence, which means that effectively she's the first recorded observer of this kind of experiment since 1854. And I think that is one for the history books.
It's been absolutely amazing to reach this stage, and to get this together and make it happen after so many years has been absolutely fabulous.